Hello there, welcome to my channel. Please like, like, and subscribe. Please like and subscribe. See us tutoring center so we can post more videos and more comment and discussion about math and engineering stuff. Okay, thank you so much. I appreciate it, and let's watch the video. Channel today. I'm going to continue with the behavior of functions. So I did the line the last time, so today I'm going to study the behavior of absolute value function. Okay, so absolute value function usually is a function that is in this form. In general, and we any absolute value function we have in this form, to graph it in the coordinate system, we call hk the vertex. The vertex of the function is hk, which means the center of the graph is gonna be at hk. So hk is gonna be a number that we going to plug in the coordinate system. So a is gonna be the slope of the line of the absolute value function. So just so you know, absolute value function look like a V. They usually look like a V, and the slope is gonna be A, and HK is gonna be the point right here. Usually, so let's say that if we have a function, for example, which is f of x equal to 2 times x minus 2 plus 3, for example. So we know that 2, 3, the vertex is gonna be 2 and 3, and the slope m is just equal to 2. What does that tell us is the vertex is gonna be at 2, 3. If I have 1, 2, 1, 2, 3, 4, 5, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so if I have the vertex at 2, 3, I count 2 from here and 3 from here. I said the vertex is gonna be at this point, and the slope is gonna be 2. So my v is going upward because the sign right here is positive. My v is going to go this way. That's the graph of my function. Okay, but if it was negative 2, my function would go like this. For negative 2, this way. So studying the behavior of a function just basically telling you you have to look at the number that is in front right here, and this number and this number. You have to look at these 3 numbers to find out. Okay, so the most basic absolute value function don't even have a k or an a, which means a is equal to 1. Okay, so, and it is exactly, so we're not going to care about k because we don't have a vertex hk, so k is equal to 0. Okay, so our k is gonna be equal to 0. So in that case, we only gonna look at h. Okay, now h is basically what is going to shift the function. If h is positive, the function is the v is going to the right, and if h is negative, like we know the formula says x minus h. So in this case, h is 2. Okay, see, h is positive, you're going to the right. H is negative, you shift the function to the left. And it's because k is 0, so it stays right exactly at the center. I mean at the x-axis, because k is not moving, k is equal to 0, you're gonna be in the x-axis. Okay, so let's see what I said. Let's make some sense of it. Let's say, for example, we have this function. Like somebody tell you, can you grab this function like I'm sorry. Somebody asked, can you grab this function? You said, oh yeah, I can graph it. Okay, I know the behavior. This is my x-axis. This is my y-axis. And he said, okay, because h equal to 3, my function is going to shift 3 units to the right because h is positive. And you said 1, 2, 3, and you see that's your point. Your v is going this way. Don't forget the slope is 1 in this case, because here, when you don't see nothing in front of here, that means there's a 1 hiding somewhere. Okay, so you don't have to write it down because it doesn't matter. So your slope is going to be equal to 1, and this is your point. Okay? And if this was positive, let's say, for example, if this was positive, you would say in this case you have h is equal to -3 because x minus h, that's the formula. So now you have x minus 3. Okay, that should give you +3. In this case, h equal to -3. So what do you say in that case? So because my h is negative, I'm shifting my function to the left on the x-axis, 3 units to the x-axis, and I said, okay, 1, 2, 3. This one is for x minus 3, and for 1, 2, 3 right here. This one is for x plus 3 in absolute value. Okay, so that's the behavior. You already know the behavior how the function is going to look right before you start doing anything. Okay, let's say for example you have, I'm gonna do a few more so you can get an idea of what's going on. So if I have like -2, let me put, okay, -2 x whatever, I can put any number, -1 plus 1. Okay, because of this negative sign in front of the 2, this negative sign telling me my function is going to face downward. Okay, so I have 2 as slope, m equal to 2, that's the slope of my function, and my vertex is hk, which is 1 and 1. And I said, okay, I know my function is going down, so I go 1, 1. That's my x-axis, that's my y-axis. 1, 2, 3, 4. 1, 2, 3, 4. Okay, I go 1 on x, 1 on y, and that's gonna be the vertex of my function. And my slope is 2, so I go this way. This is my function. If you wanna be specific, you can find the slope. You can make sure that the slope correct to the line exactly. You can start plugging point to see exactly where the line is going to behave. But if you just want to know the behavior, how the function is going to look before you do anything, you just wanna look at it. You can just look at the function. Okay, you say, oh, hk is 1, 1. Okay, 1, 1. Boom. That's my behavior. Okay. Let's say, for example, if you have, because it was negative, it's facing down. Negative facing down. Okay? Negative facing down. So now, what happened when they give you a function, f of x mean y? Anywhere you see a function of x in the xy axis, xy coordinate, x is the x-axis, and f of x is equal to y, and that's when it is this axis, the y-axis. Okay, so now basically okay, so we see 2 forms. We already see that x minus h plus k a A is our slope, HK is our vertex, and HK basically is a shift to the function, to the absolute function. If K is 0, H moving it to the right when H is positive, to the left when H is negative. If it's HK, you have to find K, so you can find the point. It's gonna be outside the coordinates, the axis system. So it's gonna be in the coordinates somewhere in the coordinate system, but not exactly on the axis. Okay. If one of this is 0, one of this is 0, that's gonna make it in one of the axes. If K is 0, it's gonna be on the x-axis. Is H is 0, it's gonna be on the y-axis. Okay, so just if you ask a function, if you ask the question, what if H is 0 right here? So that's basically telling me that my function is gonna be somewhere in the x-axis, in the y-axis, I'm sorry. Okay, so now, what if someone tells you, okay, can you graph this function? Can you graph this function? This y represents f of x. Okay, so what you're gonna do is, when we were doing f of x or y equal to 2 times 2 absolute value of x minus 3 plus 3, something like this, we were considering this as x-axis and this as y-axis. Okay, so when we have to do it this way, that's basically telling me, instead of going up like this on the y-axis, instead of taking the y as the image of x, I'm going to take x as the image of y, which means my function is going, my v is going this way when a, the slope is positive, the sign in front of the slope is positive, and it's going the other way, on the left way, when my slope is negative. Okay, so what I mean by that is, for this specific case, I'm still considering HK as the vertex of my function, but I'm going to do it another way. Let me do a simple one first. Let me do a simpler one. Let's say we have y plus 3, absolute value of y plus 3. Okay, so what do? You said, okay, I know y, x is the image of my function and y is the variable. Okay, y is the variable of the function x. So I said, okay, if this x y here and y here, x is my image. Okay, the sign here is positive, so that tells me that if this sign is positive, my function is going, my v is going this way. Let me do the just like that. Okay, I'm saying, okay, my sign is going this way, it's going this way, because my sign right here is positive. What if I have x equal to absolute value of y? I said, okay, my sign is going this way. Okay, because of the negative value is going to the left side. So adding a hk, like x equal to a y minus h plus k, is the same situation as when x was the variable, and previously when x was the variable and y was the function of x. It's the same thing. We're gonna have the vertex hk, and we have the slope m. My slope is gonna be right here, and my vertex is gonna be hk. It's the same thing. So hk just represents a shift to the function. The same thing. If k is equal to 0 and my slope is 1, if k is equal to 0, if k is equal to 0, that's telling me that my vertex hk, this is 0. If y is, k, this is gonna be 0. Okay, so if y is 0, that's telling me h is 0. In this case, where is my vertex? At 0, 0. So 0, 0 is right here. You see this? And my function is just going to be a times absolute value of y. Okay, so a is the slope. A is the slope is just telling me how big my function will open. Is it going to be open this way, or is it going to be this way, or is it going to be tighter, or is it going to be tighter? Okay, so A is basically, how do I call it? It's just telling you how big you're stretching the function. Are you stretching it that much, that much, that much, or that much? That's basically what A is. It just, that's what it does to the functions. So you can see, when I simplify everything, I got the vertex at 0, 0, which in these two cases, that was right here. The vertex is at 0, 0. So now in this case, you just care about the sign in front of the absolute value to know if your function is gonna behave on the left, open to the left, or is it going to open to the right. Now again, I said if it's positive, it's going to open to the right, and if it's negative, it's going to open to the left. Okay, so let's review a little bit. For these four cases, what we're gonna have, you can say for this one, my x is the function, my y is the variable. So if this is x, this is y, my function is going to behave, remember 0, 0, my h minus h is 0, plus k is 0, so 0, 0 is at the center. I said, okay, I'm going to the right. My function is open to the right, absolute value function. Okay, so if it's negative, I'm saying, okay, it's gonna be basically the same graph, except it's going to open to the right, to the left instead of to the right. Okay, when I have y equal to x, negative x, so now it's gonna be, okay, my function is open downwards, but still at the center, y, x. Okay, and for this case, I said, okay, my function is just open up this way, x, y. So if you combine all these focuses together, you're just gonna have something like this, which represent the behavior of two lines that we studied the last time, with x value right here and y value, y axis. Okay, so that's gonna be for up, positive y equal to x. That's for negative y equal to x, y equal to negative x. So this is negative x equal to negative y, and that's for positive x equal to positive y. That's the four cases. This one, this one, this one, this one. Okay? So that's basically the behavior of absolute value function. The only thing is shifting. I can take this function, I can shift it up, up, up. Remember, this is h, this is k for a function y equal to absolute value of x. So it's k up, k up, k up, plus 3. If y plus 3, it's like this, 3. Y plus 4, 4. Y plus n, all the way n, is going to be in the x-axis. Okay, so if it's negative y plus 4, so x plus 4, I'm sorry. Okay, so it's negative 4. You said, okay, it's going to be up and down at negative 4. So this is basically the amplitude of the function. I call it amplitude when it doesn't have a, just call it shift. It's a shift to the function. Okay, so if it's 5, my function is at 5, my vertex is at 5, because h is 0. So if h was, let's say 2, I would just say, okay, 1 2 3 4, 1 2, so it's 2 5. In this case, I would have y equal to x minus 2 plus 5. So this will be y here, x minus 2 plus 5. Okay, so that's the 0.25 y here. 2 negative 5. Yeah, 2 5. My function is this negative y here. Okay, so that's how it is. Negative 5, because if it's plus 5, I have to go all the way up y here. If it was y equal to negative x minus 2 plus 5, my plus 5 is up, so I would have to go 3 4 5 and 2, and my function would go down. You see, so you see where is, you see minus x minus 2 plus 5, k is plus 5, is up over here, and minus x minus 2 minus 5, when k is negative 5, so it's gonna be down right here. And it's gonna be, if you can see right here, there's gonna be a mirror right here. You see? The vertex is mirroring, and they both going down. Okay, so basically that's the behavior of a absolute function. Absolute function is basically a v function, and it's shifting depending on how much is h and k, which are the vertices of the function. So if one is 0, we know that we're gonna be somewhere in one of the axes. If h is 0, we're gonna be somewhere, depending on if we have y equal to x. If h is 0, we're gonna be somewhere on the x-axis. If k is 0, we're gonna be somewhere on the y-axis. Okay, so yeah, that's all about absolute value functions behavior. So we know how our absolute value function is going to behave before we basically do anything. We already know, we said there is 4 ways. As a review, I can have y equal to absolute value of a, absolute value of x minus h plus k, and our vertex is hk, and our slope is m equal to a, and we can have y equal to a can have x equal to a absolute value of y minus h plus k, and our vertex is still going to be hk, and our slope is still going to be a. So we know if this number is negative, our v is downward. If this number is positive, our v is going to be upward. In this case, it's the same. If a is positive, our v is going to be open to the right. If a is positive, our v is going to be open to the left from the axis, from the coordinate system. Okay, x, y. That's all for today. I hope this helped. Don't forget to subscribe, please. Subscribe. Don't forget, like, and subscribe. Thank you.